We're ready to work on the lesson 14 questions from the textbook. So grab your textbook, a periodic table, and make sure you have the isotope graph in front of you. I'm not going to lead you as much in these questions as I did in other ones because you have your textbook to look up questions, you have your notes that I went through, your worksheet. You can ask for your worksheet back, and you guys are going to work through this with your partners. So remember, these are to be written either in full sentences, or you can write the question out, or in the case of where you're writing a chart, you can just make sure I know what you're trying to answer so that I don't have to look at the questions to see your answer. So questions number 1 and 2, you're explaining the relationship between the word atom and element in number 1 and the word atom and isotope in number 2. So take a few minutes. They're asking for more than the definition here. They want to ask they're asking you how they're related. So you can hit pause and answer those 2 questions. Number 3, find these elements on the isotope graph. How many stable isotopes does each element have? So I'm going to help you with oxygen so you can see. So the first thing you have to do in order to use the isotope chart is to find oxygen on the periodic table, find its number of protons, which is 8, and I've lost my little chart here. Sorry, it's over here. Okay, so which is 8, and then I go to this chart and I find 8 on it. So we're going to need to kind of go up on it a little bit. I'll make it a little bit bigger so you guys can see. Go down. Okay, so here's 10. If I go right up this line, it's 10. And then this is 9, and this is 8. So this is oxygen right here. Now, when you're looking for stable atoms, it's asking you for stable isotopes. Remember that stable are all the black ones, those are the most abundant ones, and all the gray ones. Those are other isotopes found in nature. The white ones are radioactive. Radioactive isotopes are unstable. So if it's white, it's unstable. If they're black or gray, they are stable. So we'll go back to oxygen, which are right here. There's 1, 2, 3 forms of oxygen, and they're all stable. So when you go to answer on your sheet, you'll say that, and again, you can write yourself a little chart that says stable isotopes, and then you could write oxygen-3. There's 3 of them. So you do that for each of those. Look up the atomic number first, and then look it up on the chart. You're looking for gray and black ones. The white ones are radioactive, and they're unstable. Go ahead and hit pause. Number 4, use the isotope graph to determine which of these isotopes would be found in nature. So again, when you go to write this, write found in nature, and then write these down, and you can just put yes or no next to them. So the first thing you do is look up on the atomic chart their atomic number, as always, on the isotope chart. And then what you want to do is, if this has 12 protons and its mass is 24, you're looking, is there something with 12 protons and 12 neutrons that gives you that mass of 24? If so, then that can exist. Same way here. Do 81 minus 35. Do you have something with 35 protons or whatever that answer is in neutrons? If so, yes, it exists. If not, you say no, it doesn't exist. Go ahead and hit pause and finish that one. Number 5, what does the diagonal line on the graph represent? I mentioned this more than once, and by that they mean this line going up through here. I told you what that represented a couple times on the worksheet in the beginning and on the first set of notes. So if you need to, go back and look at that. And you could probably look right there in your book for an answer. Go ahead and hit pause. Number 6, use the isotope graph to find the isotopes described below. In each case, give the isotope name and the chemical symbol. So remember the name like is carbon-12, and then the symbol would be carbon, and then it would have 12-6. Okay, that's with your C and the 12-6. So don't forget name and symbol. So the first one, find 3 isotopes with equal numbers of neutrons and protons. Okay, so we want to make sure that we're looking for something that has equal numbers of neutrons and protons. 3 different elements. And remember, there's a clue on that chart where you can find that. Letter B, find 2 isotopes with the same number of protons. Okay, so obviously this is going to be the same element if it's got the same number of protons, right? That's the identity of the element. Go ahead and hit pause. Letter C, find two isotopes with the same number of neutrons. And so this is going to be different elements, but you just need to find some that when you subtract the mass minus protons, you end up with the same number of neutrons. Go ahead and hit pause. Letter D, find two isotopes with the same atomic mass units. Okay, so what will happen is when you add the protons and neutrons together, their atomic mass will equal. So this is going to be two different elements also, and will not be the same element. Hit pause. Number 7. Is an atom with a nucleus of 31 protons and 31 neutrons a stable isotope? Why or why not? Okay, so that's a 1-to-1 ratio. Remember what I said in the notes about a 1-to-1 ratio. You can also look that up in your book. Go ahead and hit pause. Number 8. Draw basic atom models for all the stable isotopes of oxygen. So you're going to draw your regular atom models. Go back to our chart, and we saw that here's oxygen, has 8 protons. So we've got 3 stable forms of it. So you're going to draw all of them will have your 8 protons, and then these ones will have different numbers of neutrons. You just look across and figure out what they are. And then all of them will have 8 electrons because they're stable and neutral atoms. Go ahead and hit pause and draw those. Okay, so we're on number 9. Name 5 elements on the periodic table that have only radioactive isotopes. Determine the neutron to proton ratio for each of their isotopes in decimal form. You don't have to do this decimal form part, but we want 5 elements that only have radioactive isotopes. So when you bring this up, that means that when you go up this line, all of their isotopes will be white. They'll have the little white, because remember we said that, if I go back over here to the chart, that white are radioactive isotopes. So you're going to find a line and go straight up it, and everything sitting on that line needs to be white. Okay, so for example, if you followed this line, these both are white. So whatever this element is, they have nothing but unstable or radioactive isotopes. So then they say, once you figure that out, because you have to do 5 of them, and then it says determine the neutron to proton ratio for each of the isotopes. They say in decimal form, but I don't need you to do it in decimal form. For instance, if let's take, let's find one that's right on the line. It's real easy to read. Right here. Actually, we've got one below the line and one above the line. Okay, so if I come down this line, which is hard, let me shrink this out so we can see. And come back up here. Okay, so we know that these are all on the same line and it's all the same element. So it's element 85. So if I look up element 85, and that'll tell me which one it is I have. And actually it's up here too, so AT, whatever that is. And then when you look at it closely again, so you guys will have an easier time to read this than when I'm trying to do this here. But when you look at it closely again, you can see that this one's right below the 125 line. So it's 124 and 126. So it's going to be 126 neutrons to 85 protons and 124 neutrons to 85 protons. So that's what they're asking you to do. So just pick 5 and do that. Okay, number 10. How many protons could a stable atom with 90 neutrons have? Which elements would these be? So how many protons would a stable atom with 90 neutrons have? So go to your chart, find on the left-hand side 90 neutrons, and then go across, look for stable ones. Those are anything that's not white, and then name those elements. Go ahead and hit pause. Number 11. Would an atom with 60 protons and a mass number of 155 be stable? So again, 60 protons is your identity. This is your total mass, so do 155 minus 60 to get your number of neutrons, and then just go look on the periodic table and see if you can find that. Is it stable? If it's stable, it'll be black or gray, not white. Go ahead and hit pause. Number 12. Which of the following isotopes are likely to be found in nature? Identify the element by name if it is an isotope that might be found in nature. So you're going to go look and see, is there something at 63? And then remember, you're going to do 162 minus 63 for the number of neutrons. So if there's something at 63, and whatever that answer is, then yes, you've got something that could be found in nature. If there's nothing there, you're going to say no. Okay, the number, go ahead and hit pause. Do that one. Number 13. The diagonal line on the isotope graph above represents nuclei with, and I know this is a multiple choice, but at this I just want you to pick the one you think is right and finish the sentence. So write the sentence out. So if you think the diagonal line on the isotope graph above, and that's the graph we've been looking at, represents nuclei with the same number of protons, you just write that out as a sentence. So pick your choice out of here and finish out the sentence. Go ahead and do that. Last question. In general, elements with an even atomic number, and then what you want to do is go ahead and look at those elements with an even atomic number and see which one of these best fit. They have only one isotope, have more isotopes than those with an odd atomic number, have the same number of protons as neutrons, are halogens. Whichever one seems to fit the best, and you're going to have to be looking at your chart to see that, at your isotope chart, and then finish out the sentence and just write that. So don't just write a letter there or it'll be wrong. Okay, when you finish those, staple them together to the back of your worksheet. If you hadn't finished your worksheet, you need to make sure that's done. Staple them both together. You're turning them both in whether they are finished or not. Okay guys, that's it for today. See you Friday.